Hey everybody, this is Mr. Beckstrom, and today I'm going to look at an example from section 9.1. This is number 7 in the homework, and it says plot the point 5, 7 pi over 6, this is in polar coordinates, given in polar coordinates, and find other polar coordinates, r theta, of the point for which the following are true. And then it gives us some criteria, and it wants us to find a point. So here's the idea. The idea is this: in the rectangular world, that's the XY world, um, we usually define a point really only in one way. Like, for example, if we have a point that is 2 units to the right and 3 units up, there's really only one way to describe that unit there. We call it 2, 3, 2, 3. And that tells our reader, or the person looking at it, that you move 2 units to the right and you move 3 units up, and then you will find that point that you're looking for, right? There's really no other way to put coordinates in here that's going to find this exact point, right? Because here you can only move 2 to the right, right? If you move any other value to the right or left, you're not going to get exactly on this vertical line. And the same is true for that horizontal line that that point is on. So the purpose of this exercise here is to show you that with polar coordinates, this property is not so, that we don't have this kind of uniqueness that we do with the rectangular coordinate system. So let's see why we don't. And then they're going to actually kind of, and this is what our examples are going to be. So here we have the point, a radius of 5, so that means that the distance from the origin out to that point is a distance of 5. And the angle starting from the right positive x-axis going counterclockwise is 7 pi over 6, given in radians here. So let's go ahead and plot that point, right? So here, 6 pi over 6 would be pointing due west or right to the left. So 7 pi over 6 is another 30 degrees around. So we're looking at something that's going to look probably something like this. This distance here is going to be 5, because that's our radius, and then we have a point right here. Now, how can this be described in other ways? Well, I mean, if we were to add 2 pi to this angle here, it would bring a complete circle, and if we still went 5 units in that direction, we'd be at the exact same point. If we added another 2 pi, it would bring it again in a complete circle, and once again, if we went 5 units in that direction, it would bring us to this point. So we can add or subtract any multiple of 2 pi and go that radius in the positive direction, right? That's a positive radius, and get to that point right there. So that's already an infinite number of solutions for, or infinite number of points that we can have. Now there's also an alternate way we can do this. We define a negative radius as going in the opposite direction, as going in 180 degrees away from whatever direction we're pointed in. So if we look at what is 180 degrees away from 7 pi over 6? Well, that would just be 7 pi over 6 minus pi, which would be, let's do that off to the side here. So 7 pi, oh, that's a horrible 7 pi over 6, but 7 pi, that's not much better, but over 6. And if we look 180 degrees away, or pi away, so minus pi, minus 6 pi over 6, that's the same as pi here, just to get a common denominator, we're going to end up getting pi over 6. And what that means is that the angle pi over 6, which is, let me do a better color here, which is this angle like right here, It's not exactly to scale, but this is the angle that's exactly a half a circle or 180 degrees or pi away from my 7 pi over 6. So if I were to say, if I were to give a -5 radius with 7 pi over 6, that means I would point in this 7 pi over 6, but I would go the opposite direction. The same is true if I were to point, so if I were to do this, if I were to go -5 in the pi over 6 direction, where would I be? Well, think about that. Pi over 6 is in this direction. -5 says I go the opposite direction 5 units, right? That's what the negative radius means, go in the opposite direction of whatever angle you're pointed at, 5 units. So this right here is going to give me the exact same as this. And I can add or subtract multiples of 2 pi to this angle as much as I want. So I have an infinite number of solutions there as well. So I can add or subtract 2 pi to the -5 radius with the pi over 6 angle, and I can add or subtract multiples of 2 pi with the +5 radius with this 7 pi over 6 angle, right? So all of those are solutions, and that should encompass every possible solution. So now let's just find out which of those fits the criteria that they're looking for here. So here they want a positive radius, which means that we have to be pointing in that direction, right? Positive radius. We have to be pointing in that direction, and we want the angle to be between 0 and -2 pi. So we want to go from this end here, right? So if this would be -6 pi over 6, then right there, that's 30 degrees less, or a pi over 6 less, that'd be -5 pi over 6. So for this A here, we'd have the radius, which is +5, because we want a positive angle, and the angle, or I could just subtract 2 pi from the 7 pi over 6 to get that, right? Because we want the positive one. So if we want a positive radius, we'll use multiples of 2 pi with this one. And if we have a negative radius, we'll use multiples of 2 pi with this one. So let's use our calculator for this just to make sure. But what I'm going to do is I'm going to do 7 over 6 minus 2, and then convert that to a fraction, and that is -5 over 6. Put the pi back in, and sure enough, that is negative. That's another way to do it. 5 pi over 6, and that fits our criteria for A, and it also gives us this point here. All right. B wants a negative radius, so we're going to use this one, and we want a value between 0 and 2 pi. Up there it is right there. We already have it. So this is going to be -5 pi over 6. And for the last one, we want a positive radius, so we're going to use this one. And we want something between 2 pi and 4 pi. Well, this one, 7 pi over 6 is less than 2 pi, so let's add another 2 pi to that. So if I do 7 over 6 plus 2 and convert that up, that's between 2 and 4 pi, right? Because that's 3.16. And convert that to a fraction. That's 19 over 6. So that would be 19 pi over 6. And that would be our answer. All right. Well, if you have any questions, let me know, and I hope you have a great test tomorrow. Thanks, everybody.